Incoming message.
Howdy everybody, what's Gucci? It's AJ here again, and today I want to talk about binary, the binary system. Binary, as you can see, is bi, meaning it has, sorry, I was thinking of something else that is not inappropriate, has two objects in it, or two ways to classify in binary. In binary you can have ones or zeros. I should make that a little bit more evident. Ones or zeros. And unlike the 10 system that we currently use, you can have 0, 0, 1, 2, 3, 4, 5, 6, 8, and 9. And so binary is a little bit different, but essentially it is the same thinking as the regular 10 decimal system we use, well, we grow up with. It just is to a different power. So for instance, let's say you're trying to figure out what the number 255 is. Essentially, what you're doing here is you're classifying each digits into a power of 10. And what do I mean by that? Let's say I put a 10 here in the corner, meaning that this is in perspective to 10. Each position indicates what power of 10 I should multiply it by, starting with 0. So as you can see here, this position should be multiplied by 10 to the 0, this should be multiplied by 10 to the 1, and this should be multiplied by 10 to 2. So as you can see, it goes from the leftmost tens place is the biggest, like in real numbers, and the rightmost is the leastmost. And what we're going to do is we're going to add up each of these digits to get the corresponding number, which obviously will add up to 255, but let me show you. So if I do 2 times 10 to the second, that equals 2 times 100, which, if you know multiplication, equals 200. Let me lower this here, guys. Oops. And now for the 5 here, I get 5 times 10 to the 1, which is equal to 5 times 10, obviously. Everything is automatically to the 1, which equals 50. And now I've got 5 times 10 to the 0, and anything to the 0 power is automatically 1. If you didn't know that, I hope you did. Equals 1, so I have 5 times 1. And so that gives me 250 and 5. And again, to come back up with 255, I just add them up, and that's how we deal with the decimal system in, I guess, overall language, because mathematics is the most exact language, and you could consider math to be a language. But now we're going to decimal. And now I'm going to try to explain decimal. Decimal is what I just showed you, but instead of using the power of 10, you use the power of 2, or use 2 as the base number. So if binary, as I told you, only works with ones and zeros. So let's say I wrote a random combination of zeros. What I'm going to do here is I'm going to do the same thing I did with the tens place, except I'm going to use 2 as the base. And that's why it's binary, bi. Try is 3, bi is 2, and then I don't know the others, but I hope you guys get it. There was another common form called hexadecimal, which I hope to cover in another video. But anyway, on the first digit, the rightmost digit, which would be the least digit, I'm going to have 2 to the 0. On this digit, I'm going to have 2 to the 1. On this digit, I'm going to have 2 to the squared. On this digit, I'm going to have 2 to the third. Then I'm going to have 2 to the fourth. 2 to the 5th, 2 to the 6th, and 2 to the 7th. Maybe I made this a little bit too long, but oops. Again, it's the same thing. So what I'm going to do here is I'm just going to look at the ones and zeros and do the same multiplication technique I did last time. So I see 1 times 2 to the 7th. Let's see, what is 2 to the 7th? I'm not sure off the top of my head. I'm going to use a calculator, and it is 128. I should know that. Computer scientists should know relative powers of 10. So it's 128 Now I've got 2 to the 6th times 0, so it's nothing. So I'm not going to do anything there. I've got 2 to the 5th, which, let's see, I hopefully is 32. Accidentally put a 0 there. Because, as you can see, powers of 2 half, so I have 128, and then if there was a 1 here, this would be 64. So now, hopefully, this is 32. And now, let's see, let's look at my number elsewise. So now I have 2 to the 4th, which is again going to be 0. And then I have 2 to the 3rd. And that's going to be something. So 1 times 2 to the 3rd equals 8. And then I've got 2 to the 1 and 2 to the 0. So I've got 1. I'm sorry, that looks terrible, guys. I have very bad handwriting. 2 to the 3rd. And then I've got 1 times 2 to the 1st, which is again is just going to be 1 times 2 to give me 2. And I've got 1 times 2 to 0, which equals 1. So now that I've got all these numbers from my binary definition, all I need to do is add them here. So I've got 128 plus 32. You don't need to include the zeros, obviously. Plus 2 plus 1. And I'm just going to add them up here. And what I like to do is I like to make it into a smaller problem. So I've got 3 here. I've got 40 here. And that's going to make 43. And then I'm going to bring the 128, so 128 plus 43, carry the 1, I believe is 171. So 171 is equivalent to 1010111 in binary. So if you want to be really cool, and you can go up to your friend and say, hey, I want to live to be 1010111 in binary. And he may not know what the heck you're talking about. But hey, you know, at least you'll sound really cool and smart. But never get arrogant, guys. It's very bad to get arrogant. Sometimes I get very arrogant. And maybe I'll share some of those stories later. But yes, for my final exercises, I'm going to show you again how to think about adding binary numbers. So let's say I wanted to add binary numbers like 1010 and 1110. Now again, these are basic binary numbers if you know how to go through the same process that I just went through. And if you wanted to add these, well, again, it's the same thing to adding decimal numbers. You just have to be aware of, except instead of using every number above 10 you carry, every number that's 2 and above you carry. So sorry, every number that's 10 and above you carry. So let's say I have 11 plus, well, I guess I'll make this 13, I'm sorry. 13 plus 18. In this example, I see that equals 11, but I don't write 11 down here. I put a 1 and I carry the 1. So that for this, so then I can go 1 plus 1 plus 1 equals 3. And that's the answer to this. Well, I'm going to do the same thing in binary, except I'm looking up for the 2, because the 2 is the place to which I'm taking respect the carrying. So if I add the zeros, again, that's 0, because 0 plus 0 is 0, and that's easy. But see, here is an example of carrying. I'm going to have the 1 plus 1. Now that's going to be 2, but in binary, as I showed you, the only possible outputs into the actual answer are 1 and 0. So what I'm going to do here is I use 2 as the carrying, the relative carrying spot. So I'm going to put a 0 right here, and then carry a 1 over here, and then I will see that 1, again, 1 plus 1, or the 1 I carried, is going to be equal to 2. So then again, I'm going to carry the 2, and well, I'm going to put down a 0 and then carry the 2. So I put a 1 over there. And what I'm going to do now is add these up, and again, I get another 0. Well, I get a 3. Sorry, I get a 3. So I'm 1 over 2. Just like if I had 11, I have a remainder of 1 after 10. I have a remainder of 1 after I divide it by 2. So I put down the 1 right here, and then I have a 2. So then again, I carry the 2 over here, and I have a 1 here. So what I do now is I I carry the 1 again to another spot, and I can put the 1 there finally because I don't get over 2, and so carrying the 1 allows me to create another transposition. And what I'm going to do here is I'm going to show you that, in conclusion, this adds up to the correct answer. So right here I have 1, 0, 1, 0, and 1, 0, 1, 0 is 1, 2, 4, and 8. So this is going to be equal to 10 because I'm adding the 8 and the 2 together, as I showed you, because 1 is obviously 2 to the 0, 2 is 2 to the first, 4 is 2 to the second, sorry, and 8 is 2 to the third, and I'm just looking for the 1s and 0s to add them up. If you do this enough, you kind of start to think of like that as well and get good at this. And the other number was 1, 1, 0. So again, that's going to be 8 plus 4 plus 2. So I can't really do it without it. So it's going to be 14. So it's going to be 14 plus 10. It's going to give me 28. And the number I came up with after adding it, oh sorry, not 28, is 1, 1, is 24, my bad. I definitely don't want to make a mistake and have someone point that out, is 1, 1, 0, 0, 0. So again, I have 1, 2, 4, 8, and 16 this time. So again, 16 plus 8, hey, equals 24. So this did work. This multiplication did work. So remember that in binary, when you add numbers, you're taking it with perspective of 2. And you do the same thing in minusing if you have to take a digit away from another number. I hope you guys all enjoyed this video, and this is getting kind of long. Have a